The year is 1943, and the air war over the Southwest Pacific is a brutal laboratory where American industrial might is being tested against Japanese tactical ingenuity. On one side stands the A6M-0, light, almost fragile, yet an absolute masterpiece of maneuverability, capable of turning tighter and climbing faster than anything the Allies possessed. The Zero's success lay not in heavy armor, but in its ability to execute the swirling, close-quarters dogfight, a style that perfectly matched the veteran Japanese pilot's skill. The American counterpoint was the Lockheed P-38 Lightning, or the fork-tailed Devil, a statement of brute force engineering. It was fast, heavily armed, and boasted twin engines for long-range escort. However, in the chaotic low-altitude engagements over New Guinea, the Lightning was consistently being defeated by the Zero in the critical opening seconds of the fight. The pilots knew the grim truth: the machine was killing them. The problem was not a flaw in the engine or the armor. It was an almost invisible defect, a minute amount of slack in the control cables. These cables, running thousands of feet from the pilot's stick, accumulated a small negligible amount of play. Though deemed within tolerance by the official manuals, this fractional delay was lethal. When the P-38 pilot moved the controls, the machine paused for a precious, lethal half-second before the control surfaces responded. The highly responsive Zero pilot, exploiting this mechanical stutter, could snap onto the Lightning's tail, ensuring a guaranteed kill. This was the core dilemma. A design characteristic that satisfied the factory's orthodoxy was actively costing the lives of men on the front line. The pilots returned, reporting the same fatal lag. The factory's faith in the blueprint was leading straight to the funeral. The tally of lost aircraft mounted, creating a widespread sense of tactical impotence despite American industrial superiority. Jabudura Airfield, New Guinea, 1943, was the geographic and logistical nexus of this fatal design flaw. This was not the pristine, well-organized assembly line of a Lockheed factory. It was a swampy, disease-ridden airstrip carved out of the dense jungle, constantly fighting the relentless, corrosive forces of the tropical environment. The logistics chain, for all its power to deliver overwhelming numbers of aircraft, could not deliver tactical truth. The engineers in California were obsessed with complex, dramatic structural issues, such as the P-38's tendency toward compressibility, an instability that occurred during high-speed dives. They were focused on fixing problems at 600 miles per hour, while the fatal flaw occurred at 300 miles per hour in a low-speed turn. The cable slack was categorized as an acceptable tolerance, and the bureaucratic machine, relying on instrument readings, dismissed the pilot's reports. This dismissal created a fundamental disconnect. The pilot's reality was that the machine hesitated. The factory's reality was that the blueprint was perfect. The reports of mounting losses failed to penetrate the intellectual wall of the Army Air Force's industrial orthodoxy. The problem was not visible on a factory quality control sheet. It was only visible in the sudden, violent absence of a returning aircraft. It was in this desperate, forgotten corner of the war that Technical Sergeant James McKenna plied his trade. He was one of the many unsung ground crew, a man who trusted his knowledge of the machine's stress points more than any manual. He was an expert in the reality of aluminum, oil, and survival. He recognized that the regulations were killing the men, and he decided to make a surgical strike against the real enemy: flawed doctrine. Technical Sergeant James McKenna's genius lay in his ability to look past the symptoms and pinpoint the exact mechanical source of the pilot's frustration. He treated the aircraft like a living patient. The P-38's complex control system, with cables running long distances, inevitably introduced stretch and play, which the factory setting had failed to fully compensate for. McKenna recognized that the tensiometer reading, the device used to measure cable tightness, was the enemy's tool. The machine read acceptable, but the pilot felt lethal. The subtle, almost imperceptible slack was the problem. It created a minute, almost frictionless delay in the transfer of motion from the stick to the ailerons, destroying the roll authority required to counter the Zero's exquisite agility. His perspective mirrored that of other great wartime innovators, like Admiral Thatch, who disregarded established doctrine to find a life-saving solution. McKenna realized that waiting for a bureaucratic fix would cost dozens more lives. He had to be like Gunn and Thatch, improvising to save lives. He knew that the control linkage needed a non-standard level of tension, a tension that was structurally near the limit, yet necessary for combat survival. He needed a component that was tiny enough to install discreetly, yet strong enough to absorb the immense forces generated during a snap roll. He knew that the very thing the factory engineers feared, over-tensioning the cables, was the only thing that would save the pilots from the Zero's guaranteed advantage. He chose to accept the immense personal risk of engineering treason. The solution to Lockheed's complex control problem came not from a massive high-tolerance machining process, but from a simple 6-inch piece of piano wire. This choice of material was an act of profound, pragmatic genius. Piano wire is renowned for its high tensile strength, its ability to resist breaking under tension, which was exactly what McKenna needed. McKenna's revolutionary method was audacious in its simplicity. He meticulously bent the wire into a precise, simple Z-shape. This Z-shape was the mechanical key. It allowed the wire to be introduced into the control linkage as an elementary, manually adjustable tensioner. It acted as a perfect subtle wedge, bridging the unnecessary slack in the cable system and creating the non-standard tension required for immediate aileron response. It was the ultimate field hack. The installation itself had to be an act of subterfuge. Working under the oppressive, humid gloom of the Dobodura hangars, McKenna inserted the Z-wire into a hard-to-access part of the control system. The wire took up that fatal slack, drawing the cable taut and eliminating the fractional delay, transforming the Lightning's controls. This act was insubordination in the service of survival. If the fix failed, leading to a crash, McKenna faced court-martial and disgrace. This calculated defiance was born of necessity, much like the furious improvisations of Pappy Gunn. McKenna's move was a surgical strike against a technical deficiency, an act of microengineering that required immense personal courage. The moment the wire was installed, the aircraft, now perfectly tuned, possessed a hidden advantage ready to surprise the Zero with a level of control authority it was never supposed to have. The moment of truth arrived with the dawn over New Guinea. Lieutenant Hayes, the pilot scheduled to fly the secretly modified P-38, was unaware of the clandestine surgery performed on his aircraft. He noticed an unfamiliar immediate stiffness in the controls, a responsiveness that was strikingly absent in every other Lightning he had flown. The critical test came shortly after clearing the coastline, when Hayes and his flight were intercepted by a group of Japanese Zeros. The scene was instantly chaotic. The Zero pilot expected the P-38 to lumber through the initial turn, providing the guaranteed window for a kill shot. But this Lightning was a different beast. As the lead Zero committed, Hayes threw his control stick hard over. Instead of the familiar fatal half-second hesitation, the aircraft snapped into the roll with an instantaneous, violent responsiveness. The lag was gone. The wire had worked. The Zero pilot, committed to his trajectory based on the P-38's predictable limitations, suddenly found the P-38's nose where his tail should have been. The snap roll was faster than his tactical calculus could accommodate. Hayes, suddenly possessed of surgical control, transitioned from being the hunted to the hunter. He used the aircraft's brute force, its twin engines and its heavy nose-mounted cannon, to full effect, quickly dominating the confused Zeros. In a shocking span of 7 minutes, Lieutenant Hayes not only survived, but destroyed 3 Japanese Zeros, a feat previously deemed suicidal. He returned to base with a single clear message. The controls were instant. The Zero could not get on my tail. I could outturn them. Lieutenant Hayes's triumphant return ignited a firestorm of excitement and defiance that spread across the forward Pacific air bases. This was not a victory announced by official communiques. It was spread by the grease-stained whispers of the ground crews, the grassroots gospel of survival. The mechanics who had been living under the shadow of the deadly Flaw instantly recognized the brilliance and the necessity of McKenna's unauthorized fix. The pilots, possessing empirical proof of the Z-wire's efficacy, demanded the modification on their own aircraft. Their lives were the stakes, and the bureaucracy was too slow to save them. The mechanics, honoring the unwritten code of the flight line, worked around the clock, installing the secret Z-wire tensioners on dozens of P-38s. The technique was shared and taught through word of mouth and crude diagrams, becoming a standardized, yet completely unrecorded, field modification. This rapid, decentralized adoption was the ultimate demonstration of field ingenuity defeating industrial orthodoxy. The men who truly understood the aircraft rejected the factory's acceptable tolerance in favor of a survival tolerance. This pattern was a hallmark of the American war effort, where the colossal quantity was refined by localized, desperate genius. McKenna's success secured the pilots' absolute trust in their machine. The psychological burden of the aircraft's flaw was lifted. The P-38 pilot could now fly with the aggressive confidence necessary for combat. The unofficial Z-wire fix is credited with saving an estimated 80 to 100 American pilots in the Pacific theater, a legacy measured not in kills, but in the men who came home. As the P-38's kill-to-loss ratio in the Pacific inexplicably began to improve, the sudden shift caught the attention of both American and Japanese intelligence. On the American side, however, the improvement was an anomaly that flew in the face of established engineering doctrine, when the truth that a critical performance flaw had been corrected by a 6-inch piece of scavenged wire finally filtered back to Lockheed and the AAF headquarters. The initial reaction was a predictable firestorm of bureaucratic panic. A maintenance regulation had been violated, and a single enlisted man had unilaterally modified a high-performance combat aircraft. The chain of command, obsessed with accountability, initiated a formal inquiry, fully prepared to discipline McKenna. However, the weight of the evidence proved too overwhelming to ignore. The pilots, the ultimate witnesses, uniformly testified that the modified aircraft were the only ones fit for combat. The combat data, showing a sharp reduction in losses and a simultaneous spike in kill tallies for the modified aircraft, was irrefutable. McKenna's defense was his perfect record and the undeniable survival rate of the pilots who flew his fixed P-38s. Faced with this embarrassing truth, Lockheed and the AAF were forced into a silent concession. They could not publicly endorse the use of piano wire, but they could no longer deny the necessity of the increased tension. The official decision was not to punish McKenna, but to discreetly study his field modification. Engineers rapidly reverse-engineered the principle behind the Z-wire. The greatest impact of the Z-wire was not mechanical, but psychological, both for the P-38 pilots and for the Japanese forces. For the American pilots, the fix eliminated the crippling fear of the turn. They no longer had to fly under the psychological burden of knowing their aircraft carried a fatal built-in handicap. This newfound confidence translated directly into aggressive, decisive action, transforming them from cautious escorts into genuine air superiority fighters. This shift echoes the successful psychological strategy used by the P-47 Thunderbolt against the Luftwaffe. An enemy that can absorb punishment and escape at will destroys the opponent's morale. The P-38, now instantly responsive, was suddenly capable of both escape and deadly counterattack, shattering the Zero pilot's trust in his own tactical superiority. Aggression as survival. Pilots began to press their advantage. When a Zero tried to execute its signature turn-in, the P-38 pilot could counter-roll and bring his concentrated firepower to bear much faster than the Zero expected. Pilot longevity. The ability to instantly disengage or escape meant that P-38 losses plummeted. McKenna's wire didn't just save a generic pilot, it created a core of experienced P-38 aces who became untouchable. The Zero pilot, once the supremely confident hunter, found his expected easy kill suddenly snapping into him, bringing a beam of cannon fire to bear. The Japanese were masters of the turning fight, but McKenna had made the initial turn a zero-sum game that their light aircraft could not afford to lose. The ultimate irony of the Z-wire story is the final official embrace of McKenna's unauthorized fix by Lockheed. The factory, which had initially dismissed the pilot's concerns and prioritized procedural tolerance, eventually had to concede defeat to the overwhelming evidence of combat success. The blood of the pilots forced the blueprint to change. The process was slow but inevitable. Lockheed reverse-engineered the principle of the Z-wire, developing a dedicated, adjustable, and authorized cable tensioning mechanism that was structurally sound and met all the necessary regulatory requirements. This official mechanism was integrated into later production models of the P-38 Lightning, specifically the P-38J and P-38L series, which went on to become the war's most effective variants. In effect, the world's largest aircraft manufacturer officially adopted the field hack of an enlisted mechanic. This event serves as a microcosm of the entire Allied victory, the ability of the system to self-correct, to ingest battlefield reality and rapidly adapt, even when it meant admitting the factory was wrong and the mechanic was right. The Axis powers, blinded by ideological rigidity and a rigid, top-down command structure, could not achieve this level of agile adaptation, continuing to manufacture aircraft with known flaws. McKenna's legacy is enshrined not on a monument, but within the technical specifications of the P-38's most successful variants. The hundreds of P-38s that rolled off the assembly line after 1943, flawlessly executing snap rolls and high-speed counter-maneuvers, were all silent beneficiaries of the piano wire intervention. McKenna's story became a permanent, though often unofficial, part of military doctrine, while the piano wire itself was phased out by the factory's authorized tensioning mechanism. The principle of aggressive control and field modification became an ingrained part of the military aviation ethos. The AAF learned a bitter lesson, that engineers must listen to the mechanics and pilots, and that flexibility must be prioritized over rigid standardization. The Z-wire is a metaphor for the entire American war effort. Overwhelming industrial power was unleashed, but its final effectiveness was determined by the ingenuity of the individual soldier, sailor and mechanic who had the courage to improvise. From the chaotic B-25 modifications of Pappy Gun to the tactical defiance of the Thatch Weave, the greatest successes were often born from desperation and a willingness to violate the manual. Technical Sergeant James McKenna returned home after the war, likely fading back into anonymity, one of the countless unsung heroes who ensured the war's victory. His reward was not fame or medals, but the quiet knowledge that his boys, the pilots he saw off into the perilous skies every day, came home because of his small act of rebellion. The Lightning, forever associated with the twin-boom design and devastating firepower, carried the secret of its perfection in its control runs. McKenna's fix was the single most crucial quality improvement made to the P-38 in the field. The P-38's ability to outmaneuver every zero was the ultimate vindication of the mechanic's uncompromising code. The inherent problem McKenna faced was a failure not of individual components, but of systemic design philosophy. The P-38 Lightning, with its twin booms, required an exceptionally long run of control cables to transfer the pilot's input from the central cockpit yoke to the tail surfaces and the ailerons. These cables, made of braided steel, were subject to temperature changes, slight stretching under high loads, and the simple mechanical reality of their length. In the factory's controlled environment, the engineering specifications stipulated a range of acceptable tension, measured by a tensiometer. This acceptable range provided for a margin of error, a necessary evil in mass production to ensure speed and interchangeability. However, this margin of error translated directly into mechanical play or slack. This slack manifested not as a sudden break, but as a slight spongy feeling when the pilot first moved the stick, followed by the actual movement of the control surfaces. This initial fractional delay was negligible for gentle maneuvers, but in the highly sensitive kinetic environment of a dogfight, it was lethal. The highly sensitive veteran Japanese Zero pilot, trained to exploit even the slightest hesitation, would initiate his turn-in just as the P-38 pilot moved his controls. The Lightning was being defeated not by a superior aircraft, but by a microscopic window of inertia built into its own design. McKenna was the only one who correctly identified that the technical tolerance was the tactical deficiency. He consciously chose to increase the structural risk to nullify the combat risk, betting on the P-38's robust airframe to handle the extra stress for the sake of survival. The dissemination of McKenna's Z-wire technique across the Pacific theater is a fascinating study in guerrilla logistics and the unique culture of the Army Air Force ground crews. The information did not travel via telex or official memorandum. It spread through a network of pilots and mechanics, communicating in a secret language of necessity. When Lieutenant Hayes landed after his 3-kill sortie, his report was not just a tally, but a technical directive. He didn't just tell the intelligence officers, he told the other pilots, and crucially, he told his maintenance chief, "Whatever McKenna did, do it to every plane." The news traveled on the wings of gossip and urgent, whispered conversations over buzzing radios. The mechanics at Dobodura, and quickly at other advanced bases, recognized the inherent truth in the fix. They possessed the skills to replicate the solution instantly, sharing the knowledge through hand-drawn diagrams on the backs of checklists or napkins, and by showing colleagues the simple 3-step process. Find the piano wire, make the Z-bend, insert the tensioner. This field innovation was a direct cultural counterpoint to the rigid, rule-bound structures of the AAF's official maintenance doctrine. It demonstrated a profound trust among the ground crews and pilots, a trust that transcended rank and regulation. The mechanics were putting their own careers at risk, yet they proceeded without hesitation because the alternative was certain death for their pilots. This system of knowledge transfer was efficient precisely because it was unofficial. It bypassed the months of required testing and bureaucratic review, achieving widespread adoption and saving dozens of lives before Lockheed even knew what was happening. McKenna's triumph over the control system slack must be viewed within the context of the P-38's other severe early war flaws, highlighting why the Lightning desperately needed this qualitative improvement. While the Zero was nimble and deadly at low speeds, the early P-38 models suffered from design deficiencies, like engine unreliability and the infamous compressibility, effect at high Mach numbers. Lockheed was pouring enormous resources into solving these major, life-threatening problems. But these dramatic failures overshadowed the more subtle, persistent failure, the cable slack, which was quietly killing pilots every day in the low-speed turning fight. The factory mindset, preoccupied with fixing the spectacular failures, missed the silent killer. The Japanese Zero pilots, masters of observation and patience, quickly learned to exploit the P-38's known limitations. They understood that the P-38 pilot, even if superior in skill, was fighting against his own machine's inertia, a fight he could not win. The Zero's pilot's patience was its greatest weapon. It allowed the Zero to control the tempo of the fight, waiting for the P-38 to make the single, predictable mistake inherent in its design. McKenna's wire, by eliminating the predictability of the roll rate, fundamentally disrupted the Zero's operational calculus. It was the one solution that addressed the Zero's advantage directly, making the P-38 tactically unpredictable in the one scenario the Japanese had mastered. Before the Z-wire, the P-38's core doctrine in the Pacific was almost entirely defensive, boom and zoom. This required the pilot to use the P-38's superior speed and dive performance to attack from altitude, fire a quick burst, and immediately escape the area before the slower, more agile Zero could counter. McKenna's fix created an immediate tactical revolution. By granting the pilot instantaneous control authority in the critical roll axis, the P-38 could now execute aggressive, evasive, and counter-offensive maneuvers that were previously impossible. The key was the P-38's high rate of climb and dive speed, combined now with roll responsiveness. An immodified P-38 pilot could, survive the turn-in. The P-38 could immediately match the Zero's initial turn rate, disrupting the Zero pilot's firing solution, exploit the vertical. The P-38 could now execute high-speed, controlled yo-yo maneuvers, using the vertical plane aggressively. Use focused firepower. The centralized cluster of a 20mm cannon and 450 caliber machine guns in the nose became a lethal advantage. The P-38 could deliver its devastating firepower with surgical precision, shredding the lightly armored Zero in a single, short burst. The P-38 evolved from a vulnerable high-speed attacker into a highly adaptable dogfighter, capable of challenging the Zero on its own terms. The saga of the Z-wire is a stark indictment of how industrial standards, while guaranteeing uniformity, can inadvertently introduce tactical obsolescence. Lockheed's decision to accept the cable slack was a rational economic choice. It sped up production and reduced assembly complexity. In an era of needing to produce thousands of P-38s quickly, uniformity trumped performance. This prioritization cost lives. The industrial philosophy was geared toward winning the war of attrition, where overwhelming numbers would eventually bury the enemy. But McKenna's story reminds us that wars of attrition are still fought by individuals in individual duels, where the difference between life and death is often a fraction of an inch. The hidden cost of the factory's tolerance was measured in the experience and survival of the American pilot cadre. Each pilot lost due to the control lag was an irreplaceable asset. McKenna's fix not only saved planes, but crucially, it preserved the human capital necessary to fly the war successfully. The Z-wire became a symbol of the ultimate field-level quality control. The mechanics, facing the immediate consequences of flawed design, instituted a quality check that the multi-billion-dollar corporation had missed. The fix served as a constant, quiet reminder that performance must always be the ultimate standard, regardless of what the manual dictates. McKenna's willingness to commit engineering treason was not born of recklessness, but of profound moral clarity. He operated under the unwritten code of the field, a code that prioritized the sanctity of the pilot's life over the rigidity of military regulation. This act of defiance was deeply rooted in the practical wisdom of the front lines. McKenna knew that if the wire failed, he would be fully responsible. Yet the psychological cost of continuing to service planes that he knew were flawed was unbearable. He chose personal risk to mitigate collective tragedy. His story is a perfect parallel to Papigun's furious, unauthorized modifications of the B-25 Mitchell. Both McKenna and Gunn exhibited the same genius, identifying the true weapon needed for survival, regardless of the blueprint, and having the courage and skill to build it themselves. McKenna's quiet heroism was his ability to provide a solution that the bureaucratic system was structurally incapable of generating in time. He wasn't solving a logistics problem. He was solving a human survival problem with a mechanical solution. The pilots who demanded the fix and the officers who looked the other way all operated under the same moral banner. The safety of the fighter superseded all paperwork. The piano wire was an act of faith and technical rebellion that ultimately served the highest goal: victory through survival. The transformation of the P-38 Lightning is inextricably linked to the Z-wire. The fix created the conditions necessary for pilots like Major Richard Bong, 40 kills, and Major Thomas Maguire, 38 kills, to thrive. Becoming the two highest-scoring American aces of the entire war, Bong, known as the Ace of Aces, utilized a notoriously aggressive and close-range style of attack. He consistently flew into the thick of enemy formations, requiring zero latency in the controls. The instantaneous control provided by McKenna's fix was essential for this surgical high-risk approach. Maguire, equally aggressive, relied heavily on sharp, sudden maneuvers to break contact or acquire targets. The agility granted by the Z-wire allowed these aces to break the typical P-38 doctrine. They could confidently use the aircraft's vertical performance and power, knowing that if they were caught in a momentary swirl, the plane would instantly respond. The Z-wire was the unseen enabler of these legendary careers. It was the mechanical equivalent of the thatch weave, a layer of protection that gave the pilot the confidence to press his advantage. McKenna's contribution was not just saving a generic pilot, it was preserving the lives of the most skilled pilots, accelerating the depletion of the experienced Japanese fighter ranks. The sudden radical shift in P-38 performance was a profound psychological blow to the Japanese military command. Their tactical doctrine, rooted in the belief that the American heavy fighters were predictable and vulnerable in a turn, was instantly invalidated. Japanese combat reports from mid-1943 began to reflect confusion and alarm. The P-38s, which should have been easy kills when cornered, were now executing unpredictable countermaneuvers and instant snap rolls. This behavioral change negated the Zero's core advantage and destroyed the Japanese pilots' trust in their own tactical superiority. The Japanese were already fighting a losing war of attrition. When the American fighters suddenly became tactically superior at the individual duel level, The Japanese Air Force began to collapse psychologically. They were fighting a war they couldn't win numerically, and now they were fighting a war they couldn't win qualitatively. Japanese tactical manuals began to issue warnings that mirrored the Allied caution against the Zero, advising pilots to disengage immediately if the P-38 initiates a snap-roll counter. This was an official admission that the P-38 had gained tactical impunity in the one area where the Zero was supposed to dominate. The mechanical genius of McKenna's wire had initiated a wholesale psychological and tactical collapse in the enemy's air force. The ultimate irony of the Z-wire story is the final official embrace of McKenna's unauthorized fix by Lockheed. The factory, which had initially dismissed the pilot's concerns and prioritized procedural tolerance, eventually had to concede defeat to the overwhelming evidence of combat success. The blood of the pilots forced the blueprint to change. The process was slow but inevitable. Lockheed reverse-engineered the principle of the Z-wire, developing a dedicated, adjustable, and authorized cable tensioning mechanism that was structurally sound and met all the necessary regulatory requirements. This official mechanism was integrated into later production models of the P-38 Lightning, specifically the P-38J and P-38L series, which went on to become the war's most effective variants. In effect, the world's largest aircraft manufacturer officially adopted the field hack of an enlisted mechanic. This event serves as a microcosm of the entire Allied victory. The ability of the system to self-correct, to ingest battlefield reality, and rapidly adapt, even when it meant admitting the factory was wrong and the mechanic was right. The Axis powers, blinded by ideological rigidity, could not achieve this level of agile adaptation. McKenna's legacy is enshrined within the technical specifications of the P-38's most successful variants. The hundreds of P-38s that rolled off the assembly line after 1943, flawlessly executing snap rolls, were all silent beneficiaries of the piano wire intervention. Technical Sergeant James McKenna remained in the background, a man whose profound contribution to victory was often overlooked by the official historical record. He was one of the many unsung heroes of World War II, a specialist who proved that the most powerful weapon in the American arsenal was not just its industrial might, but the ingenuity and defiant morality of its individual fighting men. The story of the Z-wire is the ultimate celebration of the mechanic, the anonymous figure whose skill is measured not in accolades, but in the aircraft that return home intact. McKenna's legacy is complex. He risked court-martial to save lives. He violated engineering doctrine to perfect a machine, and he ensured the survival of the men who would become the war's greatest aces. The estimation of 80 to 100 pilots saved stands as his personal tally, a victory over bureaucracy, design flaws, and the Zero's tactical superiority. The Lightning, forever associated with the twin-boom design and devastating firepower, carried the secret of its perfection in its control runs. McKenna's fix was the single most crucial quality improvement made to the P-38 in the field. The P-38's ability to outmaneuver every Zero was the ultimate vindication of the mechanic's uncompromising code. If you want more stories of hidden heroes and technological genius that changed the course of history, make sure you hit that subscribe button right now and join the WW2 Time Vault. See you in the next story. Take care and have a nice day.